All right, today we're going to pry open the lid on the software you use every single day. We're going way past the shiny buttons and deep into the code itself to figure out how do developers really know it works.
You know the feeling, right? You're in the middle of doing something important, and then bam, the app freezes up, it crashes, or it just does something totally weird. It's so frustrating. And believe it or not, that's the exact problem that a whole field of software testing is trying to solve long before that app ever gets to your phone.
For most of us, software is basically this mystery. We put something in, we get something out, but the how is all hidden away inside what's called a black box. We just have to trust that it's doing its job, until it doesn't. But what if you could actually see inside that box?
Well, that's exactly what we're doing. We're setting aside the black box and cracking open the white box, where everything inside is suddenly visible. And this is where the real detective work can finally begin.
So, what even is white box testing? Well, the most important part is right there on the screen. The tester has complete knowledge of the source code. They're not just clicking around on the surface like a user would. No, they are literally reading the lines of code that make the whole thing run. It's kind of like being handed the full architectural blueprints for a skyscraper and being told, find the weaknesses before we build it.
And you'll hear other names for this too, but they all point to the exact same idea. Clear box, transparent box, crystal box. You see the theme, right? It's all about total visibility into what's going on. For a white box tester, there are no secrets. Okay, so you're a tester, and you have the code's blueprints in your hands. What are you actually looking for? Well, you don't just wander around hoping to find something. You've got to be methodical, like a detective with a very specific checklist, hunting for clues that point to hidden problems.
And this is where it gets really interesting, because the checklist is super specific. Testers aren't just looking for crashes. They're on the hunt for things like security holes. That's where they can spot vulnerabilities that are completely invisible from the outside. They're also checking how the code handles errors and making absolutely sure there aren't any broken or dead-end paths in the program's logic.
To make this a little more real, let's just zoom in on one of these checklist items, boundary conditions. This is a classic spot where bugs just love to hide, and it's always a prime target for any code detective.
So what does that actually mean? It means you test the absolute limits, the edge cases. So if a password field is designed to hold 50 characters, you test it with exactly 50. Then you test it with 51 to see what breaks. If a process is built to handle 1,000 items, you test it with 1,000, but you also test it with 0. It's all about pushing the code to its breaking point so you can make it stronger.
Now, to do this kind of deep investigation, testers need the right toolkit. It's not enough to just read the code. You have to run it systematically to make sure every single possible pathway has been checked for bugs. And this is how they measure how thorough they're being. Think of it in levels. First, at the bottom, you have statement coverage. This is the baseline. Did every single line of code get run at least one time? Pretty simple. But then you level up to branch coverage. This is deeper. It checks every if-then decision point. And for the most hardcore check, you have condition coverage, which gets even more detailed, testing every little piece of a logical check. The goal here is to leave no stone unturned, no path unchecked.
Okay, to really understand what makes white box testing so special, it really helps to see it in a lineup with its counterparts. It's not the only way to test software, and seeing the differences makes its unique powers crystal clear. So let's break this down. Take a look at that first row, knowledge. With white box, you have complete knowledge. With black box, you have 0. You only see what a normal user would see. And gray box is that hybrid in the middle, with partial knowledge. Now look at how that directly affects their focus. Because it has full access to the code, white box testing can find those deep structural problems and security holes that a black box test would never even know exist.
So we've covered the what and the how. But now for the most important question of all. Why does any of this actually matter to you, the person using the software every single day?
The verdict is pretty clear. Because this type of testing is so incredibly thorough, it leads directly to software that is way more secure and way more reliable. By finding those tiny flaws deep inside the code's logic, developers can prevent massive issues that could lead to things like data breaches or system failures later on.
And all of that brings us to the number one reason this is all so important. The whole point, the ultimate goal, is to find and fix all those bugs before they ever get a chance to mess up your day. It's proactive defense.
At the end of the day, that's what it's all about. There's a huge difference between software that just kind of works and software that works well.
Software built on a foundation that's actually secure and reliable. And white box testing is what helps build that solid foundation.
So, to wrap it all up, think of white box testing as the ultimate insider's investigation. It gives developers the power to look at the blueprints, find the deepest, most hidden bugs, and fix them. And the result for all of us is simply safer, more stable software.
And that leaves us with one last thought. We all have that one annoying glitch in an app we use all the time, right? So now that you know how the developers are hunting for bugs deep inside the code, what's the one bug you wish they would finally track down and fix?